Okay, so today we're going to learn how to use common logarithms. I'm going to read and do a few examples and then we'll start on the assignment. To evaluate logs in base 10, use the log key and enter log, whatever the number is. The answer will be decimals that can be rounded to the 100th place. So on your calculator is already programmed to be in base 10. And if there's not a base written, like on 1 through 5, there's no base, it's written down, it's understood to be in base 10. So the logarithm key is right below the x squared button. So we're just going to press log, and number 1 is 18. Close the parentheses and enter. 1.2553. And usually they have you carry it out 4 decimal places, but you'll have to read the directions to see how many decimal places they want you to carry that out. Are there any questions? Everybody good? Let's go to the next part. Your calculator is programmed for log base 10. Any other base must be converted by using change of base formula. To use change of base, log base A of B would be entered as log B divided by log A, in that order every time. Okay, evaluate to 2 decimal places where necessary. So on number 6, you have log base 3 of 16. Okay, and we're going to enter in a common logarithm because most calculators are in base 10. So I'm going to change it to base 10. Log 16 over log 3 changes that to base 10. Okay, so this is what is called the common logarithm. So when you hear me talking about a common logarithm, or the book is talking about a common logarithm, that's what it means. It's the fraction, okay? And then you're just going to enter it into your calculator. Now when you do log 16, you need to close the parentheses because sometimes the calculator gets messed up if you don't close the parentheses around your number, okay? So log 16 divided by log 3. And you should be getting 2.52. And it's said to round to 2 decimal places, so that's what we're going to do. Any questions? Okay, you guys do number 9 and I'll do it up here. Okay, and you should be getting about 5.45. Any questions? So this numerator you could have typed in as 2 times log 20 if you wanted to use the properties from yesterday. You still would get the same value.
On our assignment, do we have to write that out if we just do it on our calculator? Do you want us to show that?
I want to see the common logarithm that you're using because on your EOI test and on probably the ACT, they're going to ask you for those. And so I want you to kind of get it down what the procedure is. Okay, so let's look at the next part. To solve the equations where the exponent is a variable, you'll need to change from exponential form to log form. Then use your calculator to evaluate. So on 13, 4 to the 3x equals 12. So what I'm going to do is I'm going to write each of those numbers or each of those values as logarithms. And the way you do that is to just write log 4 3x equals log 12. I am writing each one as a log, and they're both in base 10, so it doesn't change the value. It's keeping it the same. Okay, and then this exponent here, this 3x, I'm going to write in front of the logarithm on the left. So now to solve for x, I'm going to divide both sides by 3 times log 4. And on this one, since you have this 3 times your logarithm in the denominator, it's really important that you put parentheses around that denominator to keep it all together. If you don't, then it's just going to take log 12 divided by 3 and then take that number times log 4 and you'll get a wrong answer. So you need to make sure and put parentheses around the denominator. So go ahead and evaluate that, and I'll do it up here. And I'm getting about 0.5975. Are there any questions?
Why does the 3x go on the other side?
Because it's an exponent, and from the properties that we were using yesterday, you put the exponent in front of the logarithm. And when you have a power to a power, you multiply them together, so you move it in front. So, like if you had log of x squared, then we wrote it as 2 log x yesterday. Okay, let's do another one. Let's work on number 14. Do you guys want to try that one on your own?
I guess.
Okay, go ahead and try it on your own, and I'll do it up here. Okay, I'm getting about 0.8860.
Can you explain how you do that?
Yeah. So I wrote each of them as logarithms, and then I took the exponent and put it in front of the log 5. And then you're going to distribute, since you have a binomial times log 5, I distributed that through the binomial. So that's how I got the 4x log 5 minus 2 log 5. Now I want to get the x all by itself, so I added the 2 log 5 to the other side and then divide by 4 log 5. Okay, so I'm going to stop recording right here and do the next couple examples in a little bit. Questions?